Okay, in this section we're going to talk about two rules, the product rule and the quotient rule. So let's start with the product rule. Now I like to start this out with a little silly example. So let me just tell you this. We know that the derivative of x to the fifth is 5x to the fourth. Okay, so we know that from the power rule. But I can also write x to the fifth like this, x cubed times x squared. So shouldn't the derivative of this product also be 5x to the fourth? Right? It should, shouldn't it? Okay. Well, some students might get the derivative, might think that to find the derivative of a product, they can just take the derivative of each factor and multiply them. But let me show you that that doesn't work. If you take the derivative of x cubed, you get 3x squared. And if you take the derivative of x squared, you get 2x. And if you multiply those together, you get 6x cubed. Well, we know that's not the derivative of x cubed times x squared because the derivative has to be 5x to the fourth. So here's what went wrong. You have a differentiation rule for sum or difference of two functions that's like this. But we never defined a rule for the product nor for a quotient that looked like that. That's because there's a special rule that you have to use for the product rule. So if you have the product of two functions, if you want the derivative of two functions, or product of two functions, f of x times g of x, then what you can do is take the first function times the derivative of the second, plus the second function times the derivative of the first. Now you can get these two terms in reverse order and it still works because addition and multiplication are commutative. But the thing you have to make sure that in one term you're taking one of the functions in the derivative of the other, and in the other term swap them. So we take the other function and the derivative of the one you haven't taken the derivative of. Now some students prefer this shorthand notation where you write it like this, where you say, okay, I want to find the derivative of u times v, where u and v are just two functions. So the derivative of uv would be the function u times the derivative of v plus the function v times the derivative of u. Now let's return to our example and let's see what would happen. If we found the derivative of x cubed times x squared using this rule, well, then u would be the first factor, x cubed. V would be the second factor, x squared. Well, then u prime would be the derivative of x cubed, which is 3x squared, and v prime would be the derivative of x squared, which is 2x. So if we applied this rule, we would take u times v prime. So I'd take x cubed times 2x, and then I would add to that v, which is x squared, times u prime, which is 3x squared. And then x cubed times 2x is 2x to the fourth, and x squared times 3x squared is 3x to the fourth. And when I add it together, aha, I got what I know is the right answer. The derivative of x cubed times x squared is actually 5x to the fourth. Now obviously you wouldn't want to try this on this product because obviously it's easier just to write it as x to the fifth. But I just use this as an example to show you. Let's use it on some other products where you would be more likely to use the product rule. Okay, so here we have a binomial multiplied by a trinomial. So I'm going to say that the binomial is u, and we're going to say the trinomial is v. So using the product rule, notice here I said u times v prime, and then you're going to add to that v times u prime. Well, u would be the first function, 1 minus 3x squared. Now, we're going to go ahead and put v prime here in a minute, but for now, I'm just showing you what I'm going to do in the next step. To get v prime, don't I have to differentiate the v function? So I have to differentiate the polynomial. So you can skip this step with practice, but for now, let's go ahead and include it. And then the next term is going to have v and then times the derivative of u. So the derivative of u would be the derivative of 1 minus 3x squared. Okay, so now let's go ahead and calculate these derivatives. The derivative of 2x squared minus 3x plus 1 is actually 4x minus 3. And the derivative of 1 minus 3x squared is actually minus 6x. So make sure you've reviewed your rules of differentiation, or you want to understand that. Now, at this point, I've actually demonstrated the product rule. So if you're asked to just demonstrate the product rule, you might be allowed to stop right here. But what I like to do is I like to tell my students to simplify within reason. So here you can simplify this. You can FOIL this together. And so I'll let you do the algebra because it's just algebra from here on out. So FOIL that to get those 4 terms. Then distribute the minus 6x to get these 3 terms. Then combine like terms to get this polynomial. Now, one of the reasons that we want to go ahead and write this is we're going to find out later that it's actually important to be able to find the zeros of a derivative. And I can't find the zeros if I leave it in this form. But if I put it in this form, it allows, if I simplify it as far as I can, then I'll be able to find the zeros much easier. Okay, here's another example. This one I've got 2x squared minus x quantity squared. Well, I don't have a rule that tells me how to take the derivative of a function squared. I only have a rule that tells me how to take the derivative of x squared. So what I'm going to do is I'm going to write this as a product where I have 2x squared minus x times 2x squared minus x. And now all I have to do is say, well, I'm going to take the first function, which is 2x squared minus x, and then notice now I'm going to skip that little step that I put in up here. I'm going to go ahead and calculate this derivative in my head of the second function. So the derivative of this is 4x minus 1. Well, then I'm going to add to that, I'm going to have the second function, which is 2x squared minus x, times the derivative of the first function, which is also 4x minus 1. Now, again, I'll let you do the algebra, FOIL this, and then combine like terms, and you'll get 16x cubed minus 12x squared plus 2x. Now notice that the solution of this, if you factor it, gives you 2x, 2x minus 1, and 4x minus 1. Now, I want you to think about something. If you set this equal to 0, you would get 3 solutions. You would get x equals 0. So we would know that the derivative is 0 when x is 0. You would get x equal 1/2, because if you set the middle factor equal 0, you get x equal 1/2, and you get x equal 1/4. Now what I want you to do in your spare time, if you want to, you can freeze the video and do this. Freeze the video, go to a graphing utility, and graph the original function, not the derivative, but the original function. And then I want you to look at the graph where x is 0, where x is 1/2, and where x is 1/4. And what you're going to find is that the graph has a horizontal tangent line at those values. Now there's different ways you could have a horizontal tangent line. It might be going up and then turning around. So right here you would get a horizontal tangent line where it turned around. Or it might be going down and then turning around back up. So you would get a horizontal tangent line right there. It could also be doing something like this, where it looks like it's going to turn back down, but then it continues up, and you get a horizontal tangent line right here. So anyway, you should be able to look at the graph at where x is 0, x equal 1/2, and x equal 1/4, and see that information. Okay, let's throw in a trig function. F of x equals x squared cosine x. Well, x squared is u, cosine x is v. So I'm going to do u, which is x squared, times v prime, and notice here I went ahead and used the differentiation notation, and then v, which is cosine x, and then u prime. So that's, again, differentiation notation. And again, you can skip that step if you want to. So let's go ahead and differentiate. So I have x squared comes down, and then we know the derivative of cosine x is minus sine x from the previous section. And then we have cosine x times the derivative of x squared, which we know is 2x. And now, simplifying this is minus x squared sine x, and then this is plus 2x cosine x. So that's the derivative of that one. Now I'll let you freeze the video, and you can work this one. Notice I used a different variable this time. I used t for the independent variable, but this one is very much like the first one I did. You have a binomial and a trinomial, and notice, I just applied the product rule. I said u times v prime minus v times u prime, and then I simplified the result. Okay, here's another one here. Now here I have x is my u, and this is my v. Now I'm going to calculate the derivative. Now I left off the little derivative sign here, so let me put that in there. So the derivative, I would take this function, x, and then multiply it by the derivative of this function. Well, the derivative of sine x minus cosine x, the derivative of sine x is cosine x, and the derivative of cosine x is minus sine x, but you're going to have a minus with a minus, so it's going to make it plus sine x. And then you take the second function, sine x minus cosine x, and multiply it by the derivative of x. Of course, the derivative of x is 1. And then if we multiply this out, we get x cosine x plus x sine x, and then plus sine x minus cosine x. So that's what we get there for the derivative. Okay, now it says here, find the slope of the tangent line to this product at x equal 1. Okay, now we already found the derivative of this. So we found up there, if you go back and look earlier, we found that the derivative of this function is this, using the product rule. So now all I have to do to find the slope of the tangent line is plug x equal 1 in. So just plug x equal 1 into the derivative and evaluate it. And when I evaluate the derivative at 1, I get negative 24 plus 27 minus 2 minus 3, and that comes out to be negative 2. So the slope of the tangent line is negative 2 for that function, is negative 2 at x equal 1. And now if you want to find the slope of the tangent line for this one at x equal pi, okay, well, I just did that one up here. So here's the derivative for that one. And now I just need to plug pi in everywhere there's an x. So I have pi cosine pi plus pi sine pi plus sine pi minus cosine pi. Well, cosine pi is negative 1, so that's going to be pi times negative 1. And everywhere I have a sine pi, those terms are, sine pi is 0, so those terms are just going to disappear. And then here I have minus cosine pi. Well, that would be minus negative 1. So basically I have minus pi minus negative 1. So that's minus pi plus 1, or if you prefer, you can write that as 1 minus pi. So, and again, that's the exact value. If you wanted an approximation for that, you would need a calculator, but a lot of times mathematicians will ask for exact values to make sure that you did it the proper way and didn't use any, try to use some clever technique where you just tried to get it from some type of utility. Okay, so that's the product rule. I'll do the quotient rule on the next video.